Hello, my name is John Parham. I'm a member of the Charlotte, North Carolina chapter of the Piano Technicians Guild, and our chapter has made these models out of pianos that were either already thrown away or were destined for the junkyard, so they continue to be useful as parts of your model. In this video, I'm going to show you how to put the model together and how to regulate it. All regulating tools are provided, and the only tools you need to assemble the model are a slotted screwdriver and a Phillips head screwdriver. The regulation techniques you're going to learn are the same techniques you'd use on a real piano. The only exception is damper timing. On a real piano, you adjust damper timing by moving the spoon forward and back. On this model, you'll rotate the action rail towards you and away from you. By regulating damper timing this way, you'll become very familiar with how critical the angle of the action rail is. When you finish regulating your model, you may want to use a spoon bender. This is the tool that you would use to regulate damper timing in a real piano. To make damper timing occur sooner, bend the spoon towards the damper tail. To make damper timing occur later, bend the spoon away from the tail. We've also included a picture to help you learn the names of the parts if you don't already know them. Now let's briefly review how an upright action works. A piano action is a series of levers. Energy input occurs at the front of the key. The further the key can travel downward, the more energy you can put into the action. Energy output occurs at the hammer. The hammer moves towards the string, bounces back, and the jack moves back away from the hammer butt. That's the energy output. At the hammer end, you can also reduce the amount of energy required by moving the hammer closer to the string. The closer the hammer is to the string, the less energy the action requires to operate. The further away the hammer is to the string, the more energy the action requires to operate. When you regulate the action, you make adjustments to maximize the use of the available energy to produce the hammer movement forward and the jack movement away from the hammer butt. Now here's what happens when you strike the key. You push down on the key and the whipping and jack move up. The jack is pushing the hammer butt forward, therefore the hammer is moving forward. When the jack toe hits the let off button, it trips, and the top of the jack moves towards the front of the key, away from the hammer butt. It escapes from the hammer butt. The hammer bounces off the string, and the catcher and back check engage, putting the hammer in the check. At the same time you're pushing down on the key, the whipping is moving, and when the spoon engages the damper tail, the damper head begins to move off of the string so the string can sound. Now let's explore the contents of your box. So this is the instructional DVD you're watching. We have a key, a larger bag, smaller bag, another bag that says extra punchings. We have the backboard. The backboard may or may not have the strike plate attached. And you have the base. So let's first attach the backboard to the base. All the screws you need are already in place. Okay, now we have our base and our backboard connected. Now let's empty the contents of the large bag. We have 4 rails: the action rail, the let-off rail, the hammer rest rail, and the hammer return spring rail. Some of the action rails may have 2 hanger bolts on them, some may have 1. Whichever version you have, it'll have a metal washer. These wing nuts and those hanger bolts, by the way, a different size than the other 3 rails, so don't get those wing nuts mixed up. The other 3 rails have a cardboard washer instead of a metal washer. You'll also notice that these screws are already connected to the action rail and they're color coded, so you just match up the colors. The hammer flange goes orange to orange, purple to purple for the whipping, and the damper is white to white. And don't get these screws mixed up. Best practice states that whatever position the screw came out of, put it back in the same hole.
Best practice also states that you should back the screw out, turn it the wrong way until you feel a little bump. That's the feel of the screw moving in a proper position, and then tighten it.
So let's put the damper, the hammer assembly, and the whip in together on the action rail. Okay, when you have it finished, make sure to connect the damper return spring and the jack return spring. And hook up the bridle strap. Pull the jack forward a little bit. Point is, you do not want it to be under this green piece of felt. So with the jack somewhere up here, take your bridle strap so it goes in this way. When you finish, make sure that you've put the parts on so the spoon is on the inside of the damper tail. This is correct. Now connect the action rail. You'll notice that all the rails are numbered. Their locations correspond to the locations on the board. The names of the rails and the numbers are on the back as well. So let's go ahead and hook up your action rail. Remove the screws. The washers go on after you put the hanger bolts in the holes. Now attach the other rails. It doesn't matter what order. So your model should look something like this. Attach the hammer return spring rail to the slot. Now let's empty the contents of the small bag that has parts in it. You'll see a front rail, a balance rail, key dip block, a key slip, a nut and a screw, gauge and a tool, and you see punchings. Separate the large punchings from the small ones. The larger punchings go on the front rail, the smaller punchings go on the balance rail. So go ahead and put those punchings on now just to get them out of the way. It doesn't matter what order, except the cardboard punchings usually go on the bottom. The felt, however, always goes on top. If you don't have the felt punching on top, you may have a clicking sound when you play the key. Let's go ahead and attach the rails. The balance rail goes here. Attach it so the balance rail leans towards the back of the key. So this is correct. That's incorrect. Put it on a little bit loose so you can swivel it side to side. Now do the same thing for the front rail. And you may want to leave it just a little bit loose. You may have to move it. You may have to swivel it. Now let's install the key. Lift up the whipping and lift it up in the front. See what I've done? You may have to swivel the front rail. Take your gauge. This is a go, no-go gauge. This length is 1 3/4 inches or 45 millimeters, and that represents a blow distance that you're going to set on your model. That is only a starting point, so I've written on here a starting point. This is 5/8 of an inch diameter for checking. You can store your tool there. You can use this end for your 1/8 inch let off, and you can adjust your capstan and your let off screw with it. Take your dip block, Run the screw through it, run the nut up on it just a little bit to keep it. On the back of your model, there's a magnet and there's a flat on the head of this screw. You can store your dip block and jig right there. This is your key slip. The key slip at one point is going to go right here. Once you've finished with it, you can store it on the back of the backboard. Let's regulate your model. After you put the key on, turn your model this way and take a look at the alignment of the capstan under the whip and cushion. In this case, you can see that the capstan is hanging off to the left. The intent of the manufacturer is that the capstan lies directly underneath the whipping. So now you can rotate your balance rail and front rails and line up that capstan. If the capstan is not lined up, especially if it's hanging off the side, it can hit the adjacent whipping. Feel it with your finger too. You don't want the capstan hanging off the edge. That feels pretty good, and that looks pretty good. Tighten your balance rail and your front rail so they won't rotate. When regulating an upright action, you're going to be working with damper timing, blow distance, let off, loss motion, jack reset, checking, key dip, and aftertouch. Let's take a look at a model that's already been regulated. We've decided on key height, we've decided how far the key goes down, and those two variables control key dip. We've also decided how far the hammer will be from the string. So with those variables in place, let's play the key, and here's what we want to see. The hammer is in check at 5/8 of an inch. See the let off, 1/8 of an inch. We want to see the damper head move at 1/3 to 1/2 the distance of the string. And also we want to see aftertouch. We want to see just a little bit of space between the jack tip and the hammer butt. We don't want to see excessive loss motion, meaning there's a space between the jack tip and the hammer butt. And after you strike the key and the hammer is in check, release the key slowly and the jack should reset underneath the hammer butt. And it does. That's what we're trying to accomplish. Now that you've assembled your model, set a starting blow distance of 45 millimeters and verify it with your go no-go gauge. Then rotate the action so the damper head begins to move when the hammer has traveled 1/3 to 1/2 the distance of the string. This is where your metric scale comes in handy. Doing the math with fractions would be much harder. The damper should begin to move no earlier than 30 millimeters. No later than 22.5 millimeters as you see it on your scale. Let's go ahead and set key height. You change key height by adding or removing punchings from the balance rail. If we want to make the key higher, we add a punching. Ordinarily we would put it under the felt punching, but as we're exploring trying to figure out what key height should be, it's okay to leave them on top. Once we do find a key height, reverse them so the felt punching is on the top. Don't set a key height so high that the balance rail pin is completely buried in the mortise. You need at least 3/16 to 1/4 inch pin insertion at the front mortise. Remove the key from the front, make sure it's down in the back, and take a look at how much key pin you have. If you set the key too high, you run the risk of the key bouncing completely off of the key pin. In this case, the top of the pin is not a good indicator that you're approaching the limit of your key height. The lower limit of key height is the key slip. Let's take the key slip, go ahead and put it on your model. Now we haven't set key dip yet, so we don't know how far the key is going to go down. The key should not hit the key slip, and in this case it is. Now that you've set key height, You're going to deal with two variables as you regulate this action. You're going to deal with key dip, which changes energy input, and blow distance, which changes energy requirement. Your goal is to produce adequate aftertouch with 1/8 inch let off, 5/8 inch checking, no excessive loss motion, and the jack resets. Each time you make a change to either blow distance or dip, you have to revisit loss motion and checking to make sure they're correct. You're going to make a change at the front end or back end, blow distance or key dip, then check loss motion and checking, then look at the jack position. Is aftertouch correct? If it's not, repeat until aftertouch is correct. As we go into the next two exercises, let's call blow distance variable 1 and key dip variable 2. In one exercise, we'll set variable 1 and then change variable 2 to make the action work. So variable 2 will become whatever it needs to be to make aftertouch work. In the next exercise, we'll do exactly the opposite. First, let's set let off. Okay, we have let off at 1/8 of an inch. We've already established blow distance to be 1 3/4 inches. So now we're going to change key dip to make that work. We have to create enough key dip to do 45 millimeters worth of work plus aftertouch. Let's see what we have right now. Well, we have a lot of loss motion. So we need to eliminate loss motion and check checking. We're going to eliminate loss motion by raising the capstan. So use your capstan tool. No excessive loss motion. The jack resets, so loss motion is okay. How about checking? We don't have enough checking. To adjust checking, hold the whip in with your fingers and then with your other hand push the back check and the wire either forward or pull it back. You're trying to bend this wire. I can tell already we have way too much aftertouch. So before we continue, let's go ahead and get rid of some of the key dip. Let's reduce the amount of input on the front end. Okay, checking is fairly close. Let's take a look. We don't have quite enough clearance. We don't have enough aftertouch. So let's create a little bit more. I'm going to take out one of these punchings and we'll try again. Checking. Loss motion is okay. Jack resets. We still have too much aftertouch, don't we? Jack resets. Loss motion is okay. Too much checking. I think aftertouch looks pretty good. So now, let's see how we did with the key slip. Push the key. The key clears the key slip. In exercise 2, we're going to set key dip and make blow distance become whatever it needs to become. So now it's time to take a look at your dip block jig. Unscrew the screw that has a cardboard punching on it. Remove the dip block. Put the screw back on. This dip block is 13/32 of an inch or 10 to 10.5 millimeters on this end. Put the flat end of the screw on the base and then screw the cardboard punching down on top of the key where it just barely touches. Now take your dip block, the thicker end, put it on the key, and does the dip block fit underneath the punching? In this case it does not. So we don't have 13/32 key dip. Let's take some punchings out to create more dip. I removed some punching, so let's try it again. We still don't have enough dip. We have 13 30-seconds key dip. So now let's adjust blow distance. First, take a look at it. We have way too much aftertouch. Before we do anything, we know we have to increase blow distance. The reason why the hammer shank is not falling is because the capstan is run up too high. Just checking. Lost motion is okay. Jack resets. We still have too much aftertouch, don't we? Jack resets. Lost motion is okay. Too much checking. I think aftertouch looks pretty good. Now let's reverse these punchings so the felt punchings are on top. We can put the key slip on it. The front of the key does not hit the key slip. That's how you regulate your model.
Hello. Good luck.
The Charlotte chapter hopes that this model proves useful to you. If we can help you in any way, please feel free to contact me. My contact information is on the screen.